Good morning. We're here live at Gear Expo 2017. My name is Randy Stott, and I'm the managing editor of Gear Technology magazine. And today I'm pleased to have with me Stephen Kendrish, who is sales and application engineer with American Stress Technologies. Stephen, welcome.
Thanks.
Can you give me some background information about grinding burn and why it's important to detect?
Okay, well, grinding burn is an unfavorable effect that happens when you overheat a part when you grind it.
Mm-hmm.
Now, what happens when you overheat it is the residual stresses become less compressive and the hardness becomes less hard, essentially. Now, if those parts aren't detected and they make it into production, into a gearbox, for example, what happens is a worst case failure or less low service life.
Mm-hmm. Okay, so can you please describe the Barkhausen noise analysis process? What does it do and how does it work?
Okay, Barkhausen noise is an effect of magnetizing in a ferromagnetic material. We have a commercial instrument that quantizes that Barkhausen effect, and in essence, this Barkhausen effect is affected by that residual stress and the changes in hardness as well.
Okay. Traditionally, gear manufacturers have used the Nidal etch process to detect grinding burn, but I think this may have some disadvantages. Can you tell me a little bit about that?
Yeah, there are a few. Nidal etch can be subjective because it doesn't give you a value like Barkhausen noise can.
Mm-hmm.
The procedures involved with it can be, even if you follow the same procedure sometime, you can get the different results, and it depends on cleanliness of the part before you do that. The biggest effects, though, can be the environmental health and safety effects associated with working with acids.
Mm-hmm. Okay. And what advantages does the Barkhausen process offer?
Well, Barkhausen isn't subjective. It gives you a number, so it's quantitative in a sense.
Mm-hmm.
It's fast, and you can get immediate feedback. It doesn't really require any material preparation. And one of the benefits I've mentioned before, we have the stress effect and the hardness effect.
Mm-hmm.
When you grind and you burn, you only see that the one effect with Nidal etch, which is the hardness effect.
Okay.
With Barkhausen noise, you can see the stresses as well, and we're looking deeper into the material than etch would see, about maybe 50 times deeper into the material.
Mm-hmm. Are there still some applications where you would want to do the Nidal etch?
There are, and unfortunately, Nidal etch has a huge head start over Barkhausen noise, so it's written in a lot of prints.
Mm-hmm.
And in the aerospace industry, for example, I know that Nidal etch is pretty much a requirement. However, with like mission critical parts or very expensive parts, once you etch them, you can't throw an expensive part away like that, so you have to go through extra steps to prevent other failure modes like hydrogen embrittlement.
Mm-hmm.
So that requires either a shot peening and baking, or you just have to bake the part. So there's extra labor involved with dealing with parts after you Nidal etch them. If you don't throw them away,
Right.
yeah, that's another disadvantage, is the scrap costs.
Mm-hmm. Okay. What are the relative costs between the two processes?
That's always a tricky question, and I'm going to approach it from a longevity standpoint and say that they're about the same.
Mm-hmm.
Granted, the upfront costs, unless you automate an etch line, normal etch is less expensive than Barkhausen noise when you start.
Mm-hmm.
But over time, you have to think of the labor, environmental, safety, and health issues, as well as the scrap costs.
Mm-hmm.
And you know, if Barkhausen is a little expensive up front, they can even out pretty quickly over a year or two. And we direct people that make that inquiry to us through our website to links that have ROI calculators, and they can determine based on their scrap rate and the process and the part they're testing on how fast Barkhausen can pay for itself.
Okay. To what extent can Barkhausen noise analysis be automated?
Well, we have applications now that range from hand scanning the whole way up to robots and beyond. It's integrated into assembly lines, and we can test millions of cycles per year. So automation is not a problem.
Now, does the system need to be taught how to inspect each part to know whether it's good or bad?
Yes, and two different, I guess, approaches when you mentioned taught. Gears, for example, if we want to automate that process and have to teach it, it's simple. You just gather the parameters off the part drawing, plug them into the machine, and it knows exactly where to go and test the part. Now, teaching pass or fail based on the actual result, that's normally done with a correlation when we have known good and bad parts.
Okay. What other defects besides grinding burn can be detected with Barkhausen noise analysis?
Okay, yeah, I keep going back to the two terms, stress and microstructure. Anything that changes the stress or that changes the microstructure within a part we can detect. So some common ones are shot peening effectiveness and just general heat treat defects, hard versus soft or some variations in between. And also recently we've been having really good success in quantifying case depth non-destructively with Barkhausen noise.
Okay. What kind of depth can you get to with Barkhausen?
It ranges. I've seen studies anywhere from, say, 30 thousandths the whole way to 300 thousandths of an inch.
Okay. And now there's another technique used to analyze stress, which is X-ray diffraction. How are that technique different from Barkhausen?
Well, X-ray diffraction is a quantitative number, and by comparison, Barkhausen is quantitative as well, but it's not absolute.
I see.
With X-ray diffraction, you get a stress value. With Barkhausen noise, you get something that can be related to stress. The disadvantages with X-ray are that we're limited to a spot size of maybe 1 to 5 millimeters at a time. With Barkhausen noise, in that same period of time, we can scan a much larger area and get some information a lot quicker. Now, at American Stress Technologies, we use both technologies. And an example of where we would use both is we do an initial scan of a part with Barkhausen noise to find specific areas of interest, peaks or valleys in the values we get, and then we'll pinpoint those spots and test them with X-ray and get the actual quantitative residual stresses.
Okay, very good. Is there anything else that you would like to share with our audience about any of these technologies?
Not right now. Okay. I think I would give them the opportunity to contact us if they have any questions, and I thank you for the opportunity to
Thanks very much for the time, Stephen. I appreciate it.
Thank you.
You have any questions?